This lecture will cover a number of basic Unix commands. It's intended as your first introduction to using the Unix operating system. We'll cover things like setting up files in Unix and looking at your files and the command line interface and so forth. We'll, along the way, go over various concepts related to Unix, a little bit of Unix history, notion of a terminal emulator, those sorts of things. Some of this may be familiar ground to you. Please be patient if so, and feel free to fast forward if you need. But this is intended for those who are encountering Unix and perhaps command line interfaces even for the first time. The lecture does assume that you are at least familiar with basic computer usage, meaning that you are comfortable with the idea of running programs, that there are files and directories or folders with which files are organized. This is true, for instance, in a Windows system or a Mac system, which you may be already familiar with. But we do not assume here that you know anything about Unix in particular. One of the first things to get used to in a Unix operating system environment is that you're dealing with a command line interface. This is not like a modern Windows GUI system, although you can get such interfaces in Unix. What we'll be doing with Unix is just the command line interface. If you've had occasion to use, for instance, the command prompt in Windows, or I think it's the terminal application in Mac, then you're familiar perhaps with the same pattern. But the idea here is that we're going to be using an old-fashioned interface where one types a command at a keyboard and the text of the command is shown on screen, and a response to that command may occur as a result of you typing, and you type another command, get more responses back and forth. Your interaction with the computer is a textual conversation where you type a command and the computer gives some response, and so it goes. No windows, no menus, no icons, no graphical representation per se at all. It's in some ways a more limited kind of interface than the GUI interfaces you would deal with in Windows or Mac. But you'll find as you work with it that the fact that there is no mouse to use, that everything is done through the keyboard, actually can make the interface faster. You have more memorization to do. It is a little less flashy in terms of its appearance, but you can get a lot done once you get used to it. So there are some advantages, even though it is a bit old school. Now, the first thing you're going to have to do, of course, is get connected to a Unix system. And you can, of course, do this by having a terminal directly connected to the computer. If you happen to have a Linux, which is a form of Unix, or maybe an Ubuntu system, for instance, at home, then you just log in straight on the terminal. Using a direct keyboard. But more often, and certainly in the courses we'll teach here, you need to connect to a Unix machine remotely. And to do this, you use something called a terminal emulator. And we'll be building vocabulary terms over here and filling them in as we go, but there's one of them right now, a terminal emulator. Terminal emulator programs are Windows programs. They exist on a Windows operating system and on a Mac. And what they do is make a connection across the internet to a Unix system or other systems, but we'll be using Unix. And they behave as though they are an old-fashioned text terminal. You type commands, you get back a textual response on a textual screen. The one I'm going to be using is SSH Secure Shell, and I'd recommend that to you if you don't have a preference. This is available for free online. You can look it up in Google. And in particular, let me fill that in here. Let me add that in our minor concepts list here so that I have it as reference material. And that would be SSH Secure Shell 3.2.9. Now, the version number actually matters, and the reason is that there are newer versions of this application that are for pay. But the 3.2.9 has been lying around for quite a while and is perfectly reliable and free. So other possibilities are PuTTY, put that in there as well, and also a free terminal emulator. So get one of those if you don't have one already on a Windows system. There are also terminal emulators on Macs that you can get. And let me show you what one looks like here if you haven't seen one before. So here is what you get when you start up the SSH Secure Shell application. And the Quick Connect button is the easiest thing to use. And I have set this up here with the host name, which is the name of the Unix machine you need to connect to. Now, I'm going to be using a local machine of my own for the lecture example here, but in practice, you'll be given a different machine name for use in class. So don't copy the ihs.dinealias.com you see there, but more likely it may be vogon.calpoly.edu or some other Cal Poly edu machine if you're doing this as a Cal Poly student. Whatever host name it is, supplied by your lecturer or by me, fill that in here, and then your username. And remember, another thing about Unix systems is that a given Unix machine will have multiple users. Now that, of course, is true for a Windows machine or a Mac even, but typically there's only one personal user of a Windows machine, so you don't pay as much attention to usernames and all. You sure do in a Unix machine. It's possible for multiple people to be using the computer at the same time, in fact, and very routine. And you need to identify yourself with a login name. I'm going to use JDoe here as an example. You'd fill in your own, whatever that may be, but here we'll use John Doe. Don't worry about the rest of this stuff. It's automatically filled in. It's configuration to connect to a server program on the Unix system that will behave as though it is a terminal connection. So this program on your machine can now connect to the Unix computer remotely, and it will appear that you're talking directly to the Unix computer. So I do my connect. And I'll get back a popped up window asking for my password at this point, and type that in. And having typed that in, I'll get a bunch of login announcements here, various things that were printed by the Unix system that I've just connected to, announcing that the current system load, how many processes there are running, stuff you really don't need to worry about. But the thing you do need to worry about is right down here at the bottom, that last line, and it varies, by the way, in its format, but this is typical. That last line is a prompt. It's telling me that it wants me to type a command now. And the prompt may have, for instance, other information. It might even have the date and time in it. It might be just a simple $sign or even a simple % sign. One of the interesting things about Unix systems is that the configurations vary so much that you got to get used to each one being just a little different. In this case, our prompt is the username and the name of the machine we're connected to. Again, that Telemon is a personal machine for this lecture, and it may be a different one if you try this out. Now, at this point, what I want you to do in the lecture, and what I will require as a hand-in via email when you are done, is that you set up, before you go one bit further, a SSH Secure Shell program or a PuTTY or whatever equivalent you'd like to have for a terminal emulator. Get that running and connect to the correct machine, which again you'll be given independently, but will probably be vogon.calpoly.edu, and perform along with me all the commands I'm going to do on this Secure Shell session, and which I'll discuss in the transcript that you can see in the handout here. We'll be going down through all of this stuff and looking at each of the commands and what they do. It makes a lot more sense if you try it yourself while I do it in the lecture. And so that is in effect an official assignment. Now, how do you hand in a transcript of everything you've done? You can always just do a cut and paste if your scroll window is long enough in your emulator, and you can see that it does scroll here. So that may work. It is also generally possible in an emulator to do something called logging a session. That's on the File menu in SSH Secure Shell, maybe elsewhere, other places, but you can hunt it up and turn that on. If you do, then everything you do is saved to a text file on your local machine, and you can then mail me that text file when you're all done. I'll leave it to you to figure out the details of your terminal emulator from this point, but remember the principal points. You can download them for free. Once you get one set up, you'll see something like this screen I've been showing you here. You need a login, a machine name. You make the connection with your password, and then you're talking to the Unix system. You need to turn on logging of a session in some way or other and record what you're doing to mirror what goes on in the lecture. Now, having my prompt here, I'm now ready to start interacting with the Unix system. And what I'm going to do is a script of various commands that I have, in fact, already myself done in advance and snapshotted the entire session, exactly the sort of thing you should hand to me, although you'll find that, of course, the prompt is a little different because you'll be logged in as you on a different machine. So you can't just snapshot this thing, I'm afraid, and hand it to me. You really do need to build one of your own. Still, it'll be very much like what you're looking at here. And so you can have this as a history to look at, and we'll kind of annotate that as we go. The first thing I'm going to do in the way of a Unix command here is simply list the files that exist in my account. And I do that with the command ls. And here's a brief aside about Unix as well. Unix commands are notoriously terse. This has a little bit to do with the history of Unix, which we'll get into as appropriate aside opportunities arise. But one brief point about that is that a lot of Unix was developed in universities by researchers. And they weren't all that concerned with user friendliness. They didn't tend to worry about whether the command was explanatory. So you might think that to list all the files that are in your account, you'd type the word list. But no, ls is the long-standing name for this command, a shorthand for list, of course, and it's easier to type. And in fact, in any case where there was an opportunity to shorten a command and make it less readable, the Unix researchers that developed this stuff in the 1970s pretty well took that opportunity. So you do have to get used to that. I can assure you that irritating though it may be initially, you get very accustomed to it after a while, and you even appreciate the fact that you don't have to type as much. So, ls for listing your files, and that's a command you'll use a great deal in Unix. Now, I don't have any files in my account right now. It's a brand new account. And I'm going to assume that you're working from a brand new one as well. If not, you may just have to work around some of the examples I'm doing here, but we'll assume that the account you deal with is empty to start with. Now, is it completely empty or not? Well, hold on a minute. Now, another command we've got to do first. Where am I in the way of a directory? Am I kind of like in the equivalent of what would be in Windows a C:root directory when I start in with a Unix account? Or am I elsewhere? I'm going to introduce the next command here, which is pwd, another one of those abbreviations. It stands for Print Working Directory. It's tempting to think it somehow stands for password, but it has nothing to do with that. Print Working Directory. And I get back a response this time. It shows the directory that I'm currently in. Now, let's do a little talk about directories and files here and remind you that in any modern operating system, the vast number of files that are on the computer are organized in a hierarchy of directories. In a Windows environment, for instance, you have your C drive perhaps, and then there's a root directory that all that everything resides under, and beneath that there might be a program files directory or a users directory or other directories that group various files in the main disk, and then beneath them can be other directories and others, so on down the line. I'm doing this a little briefly because I'm assuming it's something that you are relatively accustomed to in other computers. The term directory may not be familiar to you. You may be calling them folders instead. This is an exact synonym, directory, folder, same thing. And they exist on Unix as well as on those other machines. In fact, it is the Unix operating system that really first popularized a hierarchical file system with directories and subdirectories and subdirectories and so forth. Now, in a Unix system, there are a great many different users. So we can't all use the top level directory as our home directory. Instead, the system is organized so that there is some subdirectory, and which subdirectory that is depends, again, on the Unix system, but it's very common for it to be home. So /home, and then beneath that, the directory jdo for my home account. If your home account is msmith, you may find that you are in /home/msmith, and so on. So you're already several levels down from the top of the disk, if you will, when you log into a Unix system, and you are at your home directory. And you can find what that directory is with the pwd command. For too much longer, we're going to go run around and look at some of the other directories higher up and see what a Unix disk is organized from at the very top. But for now, we'll stay at the home directory that's a couple levels down here. Anytime you get lost as to what directory you're in, pwd will tell you. And that brings up another point, too. If you're used to this folder concept in other machines, you're probably used to having some kind of graphical explorer In a Windows environment, the File Explorer, the Chooser in the Mac environment. And these display the directories to you in a nice expanded hierarchy pictorially, so that you can easily keep track of all the different levels, and you can expand a directory and see all the subdirectories or subfolders that are under it, expand those in turn. Easier visually to keep track of what's going on. The Unix command line model expects you to do this in your mind's eye, without any display beyond just the immediate name of the current directory that we got here. You're supposed to visually, in your mind's eye, keep track of what directory you're in. Nonetheless, you are always in some directory during a command line session. And every command you do applies to that particular directory, or is at least done relative to that directory, as we'll see, starting with your home directory. Okay. Now, another thing about all the Unix commands is that they almost invariably have options attached to them. And the convention, universally, and this is almost always the case, is to express the options by adding after the command, with a space after the command name first, a dash and then one or more letters. So ls-a, for instance. Now again, be careful that there needs to be a space between those two things. You can't just run them all together. But ls space dash a, and there can be no space between the dash and the a. That has to be a single unbroken string. This introduces an option to the ls command, and it is asking, in fact, that all files be listed. We might have assumed that the first ls listed all files, but as it turns out, that's not the case. In every operating system, includes Windows and Macs, there is the concept of something called a hidden file. There are some files that you just don't want to look at every time you are perusing your directory. You'd rather have them out of the way and only see them if you make a special request to do so. These again are called hidden files in some operating systems. In Windows they're referred to as dot files because in Unix they're referred to as dot files because the convention is that if you begin a file name with a dot, a period, then it's automatically hidden, unless you indicate otherwise in your ls, as I'm about to do here. ls-a, and now I do in fact get a list of files. There's some files here apparently called .profile, for instance, or .viminfo. We're not going to worry about what they have in them right now, although I'll briefly mention that they tend to have configuration information for various programs you might run, stuff you might not really look at too often and thus don't want to see in your normal ls. They do, however, all begin with a dot. And that's the convention for hidden file in Unix. If you want to see your hidden files, use -a with your ls. Otherwise, you won't see them. That brings up another point, too, by the way. File names in Unix are remarkably flexible. Other operating systems tend to limit the characters you can use in a file name, but you can name a file, anything you like. That, in fact, that I just typed is a valid file name in Unix. Wouldn't be one you'd typically want to give, but it is valid. In fact, to be extreme about it, if you make the effort to do so, and it takes a bit of effort, you can even name a file literally blank. One blank character as the name of a file. It's a hard thing to see when you ls. It doesn't really show up except as a space in the ls output. And in fact, this is sometimes done as a nasty stunt to Unix beginners if they leave their session logged in when they shouldn't. But it's just an illustration of the fact that file names in Unix can be anything you like. For instance, I can name a file 123, 123. That's a valid file name. Much more flexible than in systems like Windows or Mac. Also, file names are case sensitive. There is a difference between the file name ABC versus a file name ABC. Not so in Windows, as you may know. Those two would be the same file. But in Unix, they are distinct files based on the case of the letters. Okay, so we now have a few basics here. The ls command, command options, working directory. Oh, a thing I didn't mention about the working directory, did you notice that the separation of subdirectories is done with forward slashes? It's /home, /jdo. If you're a Windows user, you're used to those being backward slashes. If you're on a Mac, you may be used to them being done with colon separators. The symbol doesn't matter too much. The idea is always the same, series of subdirectories. If you find it a little maddening, though, if you're a Windows user, that you have to get used to forward slashes in Unix when they are backward slashes in Windows, don't be mad at Unix for that fact, be mad at Windows for that fact, because the original / established in the early 1970s by the Unix designers was the first directory separating character. Microsoft felt the need to be a little different, even though they were in fact imitating Unix, and so they used backward slashes for reasons I'm not sure I completely understand, and that results in confusion even to this day when you shift between the two systems. Okay, so let's see. What else can we do here? If I have an A option for ls, are there other options for ls? Sure. There are about a dozen or more that are in common use, and even more than that if you get to obscure ones. If you want several options, you just list their appropriate letters after the dash. Now I'm going to have the A option and an L option. That's not a 1, it's an L. For long listing. Again, I'm hoping you're doing all this by hand as well as you run your system. And you might not have exactly the same dot files that I do, by the way. That's okay if so. What do we get with an ls-al listing here? Well, now we're seeing one line per file and getting a whole lot of detailed information. This is roughly equivalent to what would be a detail file list in a Windows File Explorer, where you're showing not just the file name, but how big it is and when it was created and other stuff related to it. So, for instance, bash or .bash logout here has this long line, and the name of the file is at the end of the line, actually. And you might guess that 2009-03-02-622 AM was the date of creation, and you'd be correct. You might guess that 220 is the number of bytes in the file, and that's also correct. JDO is listed twice here. There are two kinds of ownership of a file. One is the direct owner, and that's the first JDO. The second is something called a group, we'll get to later on, and that's the second JDO. This one here you can generally ignore. It has to do with the number of links to that file, something that's a fairly obscure point, at least when it comes to files, although we'll see with directories it's has another meaning. And then this nasty looking thing with the dash, rw dash, r dash 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 has to do with the permissions on the file. Who is allowed to read it or write it or do other things to it. Don't worry about the details of that yet. There will be a second lecture on file permissions and other deeper concepts where we'll go over this in considerable detail. For now at least though, we have a long listing, and about half the stuff in the long listing should be fairly clear. Now here again you may notice a rather Unix type of thing. There are no column headers. In a normal GUI you'd expect a column header. You would have permissions up here and owner and group and byte count or size, date of creation, etc. No such luck. Again, the Unix system model is that you're supposed to kind of know this stuff already. And it is very much made, the command line interface at least is made for techies. So you just remember what these are for. And you know, it doesn't turn out to be that hard once you've gotten used to the system for a little while. So now what I'm going to do is create a new directory underneath the home directory I started with. I'm going to create a subdirectory. And that's done with, again, a textual command, again abbreviated, mkdir, make directory. And then the name of the directory you want to have. You usually don't want to store all your files in your home directory, by the way. That's a sloppy mess when you have any significant number of files. So get used to organizing your stuff in directories if you aren't already in whatever system you may have used. I'm going to assume that you might want a 101 directory. So we'll do make dir 101. And now when I do an ls, I have the 101 directory there, even if I'm not doing a -a option. If I do ls-l, by the way, I'll see the 101 directory. No dot files now because I didn't say -a. And you will notice, by the way, there's a little D right at the beginning of that mess of permissions. That indicates that it is a directory. And most Unix systems will also show you the directories in an unusual color, like blue in our case. Okay, now I'm not in the 101 directory at this point. All I did was create it, but I'm still in my home directory. So what I want to do is change so that the current directory is the 101 directory. This is a very command line interface concept. You don't really quite reason this way with a graphical system, but if you can imagine that you might be highlighting or clicking on a particular directory, that's a similar notion. To change to a directory in Unix, again an abbreviated command, cd, change directory, and the name of the directory you want to change to. Now you'll notice that our prompt now has a 101 on it. That indicates we're in the 101 directory. Don't worry about the tilde just yet. We'll get there later. But if I type pwd, for example, then I should see home jdo 101. And that indicates I'm in the 101 directory. If I do a ls at this point, for instance, I won't see any files or directories. And again, that should not be surprising. A moment ago, I did an ls and I saw the 101 directory, but that was when I was in the jdo home directory. Now that I'm in the 101 directory, an ls would show me only stuff that is underneath that directory, which is nothing yet. I haven't created anything. Let's create a directory underneath 101 and get one more level down just to repeat the process. And that would be, hold on. Oh, I'm sorry, I should do an ls-a as well. So if I do an ls-a in my 101 directory showing dot files, apparently I do have at least 2 files in the directory, even though I just created it. And those were up at the earlier directory too. Remember when we did an ls-al, I kind of brushed by them, but there's a dot and a dot dot when we had the earlier ls-l or al for my home directory. So what are those two things? Well, they are actually valid directory names. Really bizarre looking, but I mentioned earlier that anything can be a name of a file or a directory in Unix, and we're kind of taking it at its word here. Dot is actually the name of a directory, and dot dot is yet another name. Every directory has automatically in it 2 entries with these bizarre looking names, and they represent respectively the current directory. Why you'd want to be able to refer to the current directory as just dot, we'll get to in a little bit, and then also the parent directory, so that in any directory you can always change to the one above you by using the name dot dot, which will be the directory above you. Now that's not something you see in GUI systems in more modern cases like Windows or Mac. There's not an entry in each directory that goes up and refers to the directory above you automatically. But there is in Unix, and that's the dot dot entry. Now I've added to our transcript here some callouts reviewing these concepts, and that should be in the final version you have as part of the material for this lecture, by the way. The next thing we're going to do, scrolling this up a little bit, is create underneath our 101 directory yet another directory, lab1, and do an LSL on that. So bringing back the active session here, we're going to do an mkdir lab1, and ls-l will show us that lab1 is underneath our 101 directory. Now again, remember, we're not in the lab1 directory yet. All we did was create it to move us to that directory. To move to it, I'll do a cd. But actually, before I do that, I'm going to try using that dot dot entry and see what happens if I do a cd with that. Now, you should stop the lecture at this point and guess what will happen if you aren't clear on it already. If I do a cd dot dot, and by the way, for Windows users where cd dot dot is allowed also as a command, there has to be a space between the D and the dot dot in Unix, since it really is just a directory name and it needs to be a separated thing from the cd. Cd space dot dot will move me back to, doing a little pwd here, my home directory again, because of course dot dot refers to the parent directory and I was in 101. Now, I'm going to move down to that lab1 directory, but I'm going to do it a different way. I'm going to do cd and give the complete name of the directory starting from the very top of the entire system of files in the Unix operating system here. We were in, let's see, /home/jdo, that's our current directory even, but I'm going to list that out explicitly, /home/jdo, and then beneath that another /, and there was the 101 directory, and then beneath that, after another / was the lab1 directory, right? That's the complete name of that lab1 directory. And you can always refer to a directory or a file in this manner, starting with the / at the top of the whole operating system and going down directory by directory to the one you want, the directory or file that you want. It's in fact called an absolute path name, and I'll add that as vocabulary. Absolute path name. The term path in this case describing this series of directories that is a path you take going from the top down to what you want. And an absolute one starts at the top level with slash. We've really not been doing this yet. In fact, all the things we've done so far have been relative names. I make dir lab1, and that's assumed to be relative to the 101 directory I was in and created below that. And if I cd to lab1, it would have been relative to the 101 directory. So you can also refer to them relative to the directory you're currently at. And those two alternatives are always worth bearing in mind. You can identify something by absolute path or by relative path. Absolute path begins with a slash, and that's assumed to be the top of the whole file system. A relative path doesn't, and it's assumed to be starting with wherever you currently are. So moving back to our vocabulary block, I will add those in. Absolute path, relative path. Okay. Now that I've done this cd command, I should find that I'm back in that lab1 directory, and the pwd confirms that fact. Okay. So let's see, what do I want to do at this point? Let's explore around a little bit more in the larger file system. I'm going to go back and I'll use a absolute path name to do this, just for fun, to my home directory, cd/home/jdo. Now, I'd like you also to pause and think about another cd command that would have done the same thing. Remember, I'm down in lab1 right now. So is there some other cd command that would have brought me back to /home/jdo aside from the one I just listed here? And the answer is, I'll first do the command I've got, and that does bring me where I wanted to be. But I will also go back down to jdo 101 lab1. Oops, this is going to be wrong. cd/home/jdo/101/capital lab1. Remember, we did say they were case sensitive. I used a lowercase l, and that's what screwed it up. You might have come up with this, .. If I do cd ... that goes to the directory above. Let's see, if I'm in lab1, that would be the 101 directory. But then that one has a ... in it as well. And so a second ... would take me all the way up to jdo. And in fact, you can follow the ... upward with slashes between them in a relative path name that leads you up to as many parent directories above as you want to go. So we'll do that instead. And again, we'll be at home jdo. Okay, let's see here. Being at home jdo, what happens if I do cd ... now? Well, that ought to take me up to just /home, right? And so it does. What do I got under here? Well, there are several accounts under /home, and on this small machine I'm illustrating, there are only 3. You may have many more in whatever machine you're playing around with, and that's fine. But what we would expect under home is a number of other home directories besides our own. And the point here is that there are other home directories on the operating system, on the Unix operating system, belonging to other users. If they make them readable, you can even go in and look around at their stuff, although most people protect it so you can't get in and look at it. Again, we'll talk about permissions later on. But they certainly do exist. In this course, you're going to be frequently getting information from a directory, and in particular it'll be grade_cstaley, another home directory for another user called grade_cstaley, the grader account for this class. And so to illustrate that idea, what we're going to do is go look at grade_cstaley a bit and see what's in there. Before we do though, let's go one further level up and look at what is at the very top of the full file system. Now, I could do this with cd ... to go one level up, or I can just say cd/, either one's the same. / by itself means the top directory of the entire file system, just named /. And up there, if I do an ls, I'll see all this interesting stuff. This is sort of the master directory of the entire Unix system. And it has a number of subdirectories underneath it. You don't need to know what they all do, but just to illustrate, there's home, which has all of the home directories underneath it, like home jdo. And then there's a directory of libraries. This is generally filled with different libraries of code that might be linked into different programs, and also other configuration information. There's a directory USR, standing for user, rather misnamed because people think it means home directories, but it usually doesn't. Instead, it's programs that are added beyond just the built-in standard programs for the Unix operating system, and they are called user programs. The bin directory, standing for binary, contains a whole lot of built-in programs. And here's a concept for you, by the way. All the commands we've been running, pwd, ls, cd, makedir, they are actually programs, small programs, that are running as a result of our commands and doing things like creating a directory or listing files or what have you. And the programs themselves are all in this bin directory underneath the master root directory of the entire operating system. And by the way, I will stop calling it a master directory. It is called a root directory, this top level one. So, various different things underneath the root directory. And as you learn more about Unix, you'll know more about what is in here. But for now, at least a few examples. And if we go back down to home, I don't need the slash, right, because I'm in the slash directory. I can just say cd home. That'll get me down to where we were before. And then I'm going to go down and look at grade C Staley. And then slash beneath that 101. Turns out that grade C Staley also has a 101 directory underneath it. And then lab 1. If I list that, we'll see we have a couple of files in here. We're going to be playing around with those. One of them is a C program file of C source code. Don't have to understand it yet, but we'll at least take a glance at it. The other is the output of that program. It, in fact, prints out the ever popular 99 bottles of beer on the wall song, which gives us a long file to play around with. It's important, by the way, to notice that this lab 1, of course, is not the same as the lab 1 we have in our JDO directory or in your home directory. This one is for grade C Staley. And this is one from which you will be obtaining information, by the way, quite frequently. The 101 directory underneath grade C Staley will have different lab directories beneath it, and you'll be often asked to get files from that and copy them over into your directory. So to that end, let's look at how we copy files. Now, it's easiest to copy files from some other directory to a directory you're in. So what I'm going to do is move back to the home directory that I had before and 101 lab 1 beneath that. Now, let's see, stop and think, what cd command would you give to do that? I want to go back to the 101 lab 1 underneath JDO or underneath your account. What you should come up with is that you could write cd /home/JDO/101/lab1, and that would work. But at this point, let's introduce a convenient shorthand. It gets a little tedious to have to remember exactly where everybody's home directory is. And remember, Unix typically changes these configurations, so it may not always be /home, maybe some other configuration, like, home directories or something like that, different name on a different Unix system. But you can always get to the home directory of a user with this notation. Put a tilde in front of the username, so tilde JDO, and that automatically means the home directory of JDO, wherever it is. And the necessary /home/ in our case will be added automatically in place of the tilde. So I'm going to do it that way. cd tilde /JDO/101/lab1. And that gets me back to where I was before in my home directory. Now I want to copy some files from the grade C Staley 101 lab 1 over to here. To do that, I use the cp command. Again, an abbreviation for copy. If you're used to the Windows environment, it may have used a copy copy command. Watch out, because it's a different name here, just cp. Now, you give to the cp command 2 arguments after cp. The file you want to copy and what you want to copy it into. So to be very complete, I'm going to do it like this. /home/grade C Staley /lab1 and then see, what was one of those files? Was it bottles.c? So that's one of the files I want to copy. That's the first of 2 things I list after cp. The second is what I want to copy it to. And I'll just give the same name but without all the preface, and that will mean that I'll create a file named bottles.c in my local directory and copy the other one into it. Now again, stop and think. I could have written that first argument a little differently, right? Could have been just tilde grade C Staley instead of the /home/. Do the copy command, do an ls, and there's bottles.c, copied across. Okay? Now, we haven't even looked at what's in bottles.c just yet. There are several ways to look at the contents of a file in Unix, and by the way, almost all files, except program files, for instance, are text files in Unix. Not so many different file formats, not a word processing file format and a spreadsheet format and all of that. Everything's pretty much a text file if it's humanly readable at all in Unix. And a convenient command for very quickly listing files is cat. I'll get to where that came from in a minute. Cat and the name of the file, and it will dump the contents of that file on your screen. This here is then a C source file, and again we'll look at what that means later on, but take my word for it, it prints out the 99 bottles of beer on the wall song. Now we could compile it and run it, but we're going to get to that later on in another session. For now, I'm just going to copy across also the other file, which was the song file from grade C Staley. I'm going to do that slightly differently this time. I'm going to do a cp command. I will use the abbreviated grade C Staley name for that account instead of /home/grade C Staley. And 101 lab 1 song. And then instead of listing song again as the target of the copy, and we may as well use those terms, source and target. The first argument is the source of the copy, the second the target. I'm just going to put dot here. You're always allowed to list a directory as the second thing after a command, after a copy command, and that means that whatever file you're copying goes into that other directory with the same name it had in the one it was originally in, and a copy is made. So we will get a song file copied into the current directory in this fashion, and there's a first example of the use of that dot. If you want to refer to the one we're in, the directory we're in, you just say dot. And in this case, that's where we're copying to. So now if I do an ls, I have bottles and song. And let's see what's in the song. Oh, I promised, by the way, to explain what cat is about. That is short, oddly, for concatenate. Fancy computer term for sticking a series of things together. The reason for that is that you can give several file names after it, and it'll spill them all on the screen, one right after another. And that can be useful in cases we'll see later on. For now, it's just curiosity, and the name itself is an example of very not mnemonic Unix names. Cat, just dump the file on the screen. Cat song on the screen. Yeah, that went by awfully fast. And in fact, as you can see, it's scrolling back up to what I had before. The 99 bottles of beer on the wall song. And I did this partly to get a really long file to show what it takes to list longer text files. You don't like to see a text file just go whizzing by on the screen like that. And an alternate command to deal with it is called more. So more, and the name of the song, the name of the file, I'm sorry, song. If I do this file, or this command, what you'll find is that it stops after each screenful and does this little message at the bottom saying that there is more information and tells you what % of the way through the file you are. More stuff, and we're only 4% of the way through the file. That's where it gets its name, by the way, because it keeps saying more. That's the name they gave the program itself as well. And to get the next screenful, you just hit the space bar. Hitting the space bar, there's our next, and our next, and I'm continuing to hit the space bar here to go down through the entire file. So if you want to see something screenful at a time, you use more. Except that you really don't use more unless you're 40 years old or older, because that was the command that got common early in the Unix history. These days there's an improved one, and in typical whimsical Unix fashion, they had to name it less, even though in fact it's better than more. Sorry about that, I didn't make these names up. So less song will do the same sort of thing, show you a screenful at a time, though it doesn't show the percentage. And you can get the next screenful if you like, but you can also use P, a command letter just on the keyboard, to go back up. And then back down either with a spacebar or with an N for next, excuse me, no, I guess it is just a spacebar. Spacebar for the next one, or P to go back up. And you can even scroll around with the arrow keys in more modern fashion and look around the file. More never did that. You couldn't go backwards. It was meant for older terminals that didn't even have arrow keys. Trust me, back in the 80s and the 70s, they didn't have arrow keys on terminals. We did things the old-fashioned way. But much better to have the less application now. And by the way, if you really don't want to go all the way to the bottom, and by the way, less won't stop looking at the file even if you do go all the way to the bottom, because you might scroll back up, you hit Q for quit, and that'll end your less session. Now, less does illustrate an idea that you need to get used to in command line interfaces as well. Something called a mode. A lot of the commands we've been running just do their job quickly and are done, and there's no extra input you give during the command. But less, and for that matter more, are different. You can give input during the command. The space to move down a screen, the P to go up a screen, Q to quit. And only those commands are valid when you're working with less or more. For instance, you can't do an ls while running less. You can't do a cd, you can't do a cp. The commands that apply when you're running in the main login prompt do not apply when you're running some subprogram that takes its own commands. And you're said to be in a mode when you go into one of those subprograms. We're in less mode when we're dealing with less. And you always have to remember what mode you're in and what commands apply and what don't. The applicable commands change, especially when you run some subprogram that takes a while and has its own subcommands. Remember that, and don't assume that commands at the top level, like CP or LS, will work when you're in the middle of some other program. And a term to introduce, by the way, here, you're talking to, when you deal with that top level prompt that you had when you first logged in, that's referred to as a shell prompt. Shell like seashell, S-H-E-L-L. And the shell program is what you are talking to when you give those commands. It's sort of the master user interface program, maybe a little like the main file explorer program in Windows, or the Finder in a Mac, except of course it's just text-based. So shell commands apply for the shell, less commands apply for less, and we'll see other examples later on where there are different modes in their own sets of commands. Now let's mess around a little more with files here. If I can copy files, that's great. What if I want to remove them? The rm command removes files. And you list the files, one or more after it, that you want to remove. So I'll list bottles.c and song. This is equivalent to what might be del, for instance, in a Windows environment if you use the command prompt. And they're gone. Now, I think maybe I'd like to get them back again. So let's do that with another copy. And rather than copy them one at a time from grade C Staley, I'm going to do this a little less tediously. I'm going to copy grade C Staley 101 Lab 1 and then star. Now, this means the same thing that you may have encountered it meaning in other operating systems. It's a wild card. If you put an asterisk in a file name or part of a longer path name, it means anything will match here. So having put a star at the end there, that will match both song and bottles.c. It's as if I had typed both those file names. And copy will accept multiple file names, either in the form of a star like this or literally listed out, and multiple sources then. But when you do that, the target has to be the last thing, and it has to be a directory. If you're copying more than one file, you don't give a name for each target. You assume that the files will not change names, and the only thing you're doing is copying them from some location to some other directory. So that's an alternate use of copy, either using a wildcard like star or multiple file names, and then finally a directory into which you want them all copied without changing their name. And once again, that directory will be dot, the one we're currently in. So this command then copies everything in Lab 1 from grade C Staley across. Both files are there. Okay, so we've copied them across. Let's remove them again. Again, with something more efficient. rm star, that wildcard works in lots of contexts. If you use it by itself, it means every file in the current directory. And you are looking here at the single most dangerous command in all of Unix, rm star. There are even joke cartoons I've seen with an astonished look on some beginner's face, and so discovers RM star. So don't let this be you. RM star removes, as you can guess, every file in the current directory. Now, it's not going to do any harm here, but obviously if you had a more important directory, it wouldn't be something you'd like to do cavalierly. They're gone. More importantly, and this is a little dark aspect of Unix, there's no trash can you can go get them back from. Once you do a remove, they're gone with a capital G. In fact, because there are other users on the Unix system at the same time, even the file space occupied by the files you just removed will be gobbled up like a cow in piranha-infested water. Everybody else is using disk space and making new files, and as soon as your file is released, all its space gets used by somebody else, and the contents are wiped clean within just a few seconds. So there's really no way to recover it. It's an irreversible operation in Unix, and so you become very disciplined. You get almost a cringe reflex when you type RM. And really, you should have the reflex of removing your hands from the keyboard, especially after having typed RM star, stopping and thinking, and then hitting the return when you're really sure of what you want to do. It's usually the blind reflex RM star that gets you in trouble. Okay, now I'm going to once again copy them across. And again, I'm going to try and do it even more conveniently. Exclamation CP. The exclaim is a shorthand for repeat a prior command. You say exclaim and give the first few letters of the prior command, and the first command earlier that had those letters beginning it will be repeated. Bang CP repeats the copy command I just gave earlier, much more conveniently. Now, it turns out that in most Unix shells, you can just use arrow keys as well, and I'm going to do that right now. I'm going to start pressing the up arrow key on my keyboard, and we can see that it'll go up through the prior commands or back down through them. This is similar to what you'd get in a command prompt in Windows. So if those are enabled, they're really more convenient than the exclamation mechanism. And yet sometimes a command is a while back up and you don't want to arrow all the way up to it, and the exclaim works quite well. So remember that that exclamation is available as a command, and in fact you can also do the most recent command repeated with just 2 exclamation points like that, and we'll redo that copy command again. Now, by the way, that illustrates not only how to redo the most recent command quickly, it also shows that copy isn't upset about copying onto files that already exist. We did a copy command and got our bottles.c and song.c back, right? And then we did another one and copied them over the existing ones. We hadn't removed them. Copy is that way as well. If you copy onto an existing file, it's a little like remove. The existing file is gone, the new copy is there instead, and the existing or the earlier content is not retrievable. So be careful with copy as well, if you're copying onto existing stuff. Okay, so now we're back to having bottles.c and song there. What if I want to move them to a different directory from where I am right now? We saw earlier that I can list files and with copy, so I could do it either with a wildcard or literally copy bottles.c as song. And I want to copy them, let's say, one directory up to the 101 directory that's above me. I'm in Lab 1 right now. What would that take? Think about it. Pause the lecture if you need. And coming back from a pause, you might have come up with this. Remember, ... means the directory above me, right? I can copy these 2 files to the directory above me with the ... command like that. And that would make copies in Lab 1. But you know, I don't know if I even want to do that so much as I want to move them to the directory above me. What if I want to remove them from the current directory and not make a copy, but just move them entirely up one directory? What would be like a cut and paste in a more modern arrangement. The mv command moves files. It works exactly like copy in terms of the arguments. Source, target, possibly multiple sources, and a directory target. But it doesn't make copies, it just moves the files and removes them from their current location. So if I do that, I'll have no files in Lab 1, my subdirectory, but if I go up 1 to 101, now the files are here instead. Write the move command, again pause and think about it, to put them back into Lab 1 from here. And coming back from the pause, what you should come up with is this. In lab 1, in the 101 directory, I'm sorry, I can write move bottles.c and song to lab 1 directory, and that'll put them back where they were before. Now they're not in 101 anymore, but if I go down to lab 1, they are down here. So you can move files around with syntax very similar to CP, but with MV instead. And MV will also, by the way, let you change the name of a file. In Unix, changing a name is basically moving a file. So, for instance, I wanted to move or change the name of song to long song. I do a move song, long song. And now it's called long song. So move serves as a rename also. Now, that's it for our basic lecture sequence of Unix commands. You should come away with this with an understanding of ls, cp, mv, rm, makedir, cd, relative path names, absolute path names, concept of subdirectories, current directory, the notion that there's a shell program that you're communicating with when you do all these commands, the idea that your home directory is several levels down from the top of the whole file system. And then let's do a few more Unix concepts here, kind of wrapping up, and then we'll quit this lecture. You can see that this is kind of a creaky old operating system in some respects, even though it can be very fast to work with once you're used to it. And you should understand that this is one of the earliest operating systems ever written. Unix was built in the early 1970s. It was a project at AT&T's Bell Laboratories, which was also the source of such innovations as the transistor, by the way, a very serious industrial research lab, especially in the 70s. They gave it away to universities because AT&T wasn't allowed to sell software. They were a telephone monopoly back then, and they just gave the software away. And so a bunch of universities, especially at Berkeley, in UC Berkeley, did additional development of the Unix operating system, and they wrote a lot of these commands. And with that backstory, it's not too surprising that the commands tend to be a bit of a hodgepodge. The flags, for instance, the options, -I, -A, -L, those things, are different for every command. And that's because they were often written by different people, even at different universities. After this thing had been developed at universities for a decade or so, it finally got released in general to the public in the 1980s. I can even remember when it was a big new thing to have the Unix operating system out available on computers. And it has since been replaced by Windows and Mac, which are more usable for non-technical people, but for technical uses. In servers, in laboratory environments, in academia, Unix is still very widespread. And of course there is the new version of it, Linux, which is another flavor of Unix, and it looks just like, well, in fact we're working with a Linux version as I've done this demo here, so you can think of it almost as synonymous with Unix, but it was a rewrite of the entire Unix operating system with no AT&T code involved from scratch as an open source project, and is now the most widely used version of Unix. You should be aware, though, that there is a BSD, Berkeley Standard Distribution. It's one of our vocabulary lists up here. And I'll add Linux, by the way, to that, too. A BSD version, which is the Berkeley Linux, or Unix that was developed in the 1970s and is still in use here and there. So different versions of Unix, BSD and Linux in particular. Okay. The command line argument, or command line interface, you've gotten familiar with here. We've talked about prompts and commands and arguments and all. You've got to do internal visualization. It's faster. You don't have to use a mouse. The idea of modes and all. So those concepts we've covered. You address the system through a terminal emulator. We covered that idea as well. Used to be a physical terminal, but now you do it virtually. We have the files and directories, case-sensitive names. Let's see here. And a little bit more about the underlying structure. I mentioned that briefly, but the Unix operating system itself is really a big library of code that does basic operations like input and output and managing running programs and so forth. And that part of Unix is called the kernel. What you see of Unix is actually programs that are written separately from the core of the operating system to help you do things like make directories and so forth, as I mentioned earlier. The program you talk to when you start your login is a shell program, and then when you run the commands, you're running other smaller programs. So be aware that you're really running a bunch of cooperating, independent programs when you work with a Unix command line session. And beneath it all, almost invisible to you, is the real Unix operating system, which these programs work with to get things done like input and output of data and managing, sharing the CPU and so forth. Okay, there's our Unix introduction. The next session we'll talk more about permissions and some more advanced commands and editing and so forth. And I do need to add one final command before we leave here. You might like to be able to end your Unix session, and you do that with a simple command, logout. And that terminates the session. Your secure shell can then be shut down if you like, and you are officially logged out.